Today, I'm going to be solving this integral from the 2023 MIT integration bee. Before we start solving this integral, we should understand what the floor function and the ceiling function represent. The floor function represents rounding a number down. So if I have the floor of 0.5, that's going to be rounded down to 1. The ceiling represents the opposite and it rounds a number up. So if I have the ceiling is 0.5, I will round it up to 1. So now to solve this integral, I'm going to rewrite it as a summation. I will rewrite this as the sum from n is equal to 0 to 99 of the integrals from n to n plus 1 of the floor of x times the ceiling of x. In other words, I'm rewriting this massive integral into these smaller integrals. Since an integral is the sum of the areas under a curve, this is the sum of those individual areas. Another way of thinking about it is, instead of writing the integral from 0 to 100, I'm summing up the integrals of 0 to 1, of 1 to 2, of 2 to 3, and so on. So the integral of 0 to 100 is going to be equal to the integral of 0 to 1 plus the integral of 1 to 2 plus the integral of 2 to 3, and so on. I'm summing up each of the individual areas under the curve to get this final integral. Now I can rewrite this as summation as from n is equal to 0 to 99 into n plus 1. What I can do is I can replace the floor function with n, and I can replace the ceiling function with n plus 1. This is as the maximum value of the integral for each of the iterations is going to be n plus 1, and the minimum value will be n. And from the definition of a floor, the minimum value is going to be equal to the floor each time, and the maximum value is going to be equal to the upper bound, which is n plus 1. So now what we can do is we can take this n times n plus 1 out of the integral. So we get the summation from n is equal to 0 to 99 of n plus 1, and then the integral. This is as for each iteration, n times n plus 1 is going to be a constant, and because of the constant rule, we can take it out. Now that we have this, there are two things that we can do. We can expand the expression, so we get n squared plus n. And then this is a pretty trivial integral. This is the integral of x. So it's going to be x squared by 2 over n plus 1 and n. So this is going to be n plus 1 squared minus n squared by 2. So now what we can do is we can rewrite the summation again. So we get from n is equal to 0 to 99. And here, this is going to be equal to n cubed plus 3n squared by 2 plus n by 2. And this is going to be equal to 24997500.